Did you know that you use the same secret-keeping technology as World War II spies every single day? Every time you send a text, check your bank account, or buy something online, you are using this technology. It's the single most important concept in all of cybersecurity. Last time, we talked about VPNs and said they protect by putting data in an encrypted tunnel. We've been using that word, encryption, since video 1. We said it's like an armored truck, a locked box, or unreadable rubbish. But what is it? How does your phone actually turn a message into a secret code, and how does the other side read it? At Teleris, we aim to protect businesses and organizations from cyber threats. The world of cybersecurity is advancing, and so are our expert AI agents. Visit us at teleris.com to find out how we do this. But the truth is, the core concept isn't complex. It's as simple as the secret decoder ring you had as a kid. Today, we are finally pulling back the curtain. We'll show you exactly what encryption is, how it works in plain English, and why it's the invisible hero protecting your entire digital life. Encryption 101, the secret decoder ring. Let's forget computers for a minute. Imagine you want to send a secret message to your friend. The message is, meet. You don't want anyone else to read it. So, you and your friend agree on a secret key. Your key is shift by 1. You take your message, meet, and shift every letter forward by 1. M becomes NE becomes FE becomes FT becomes U. Your secret, unreadable message is now NFFU. If I told you that randomly, you wouldn't understand. This is ciphertext. Your original message, meet, is plaintext. The process of turning meet into NFFU is encryption. The secret rule, shift by 1, is the key. You can now pass this note in public. If anyone intercepts NFFU, it's just nonsense. But when your friend gets it, they use the same key in reverse. They shift every letter back by 1, and NFFU becomes meet. This reverse process is decryption. Congratulations, you've just performed symmetric encryption. Symmetric just means the same key is used to lock and unlock the box. This is the oldest and fastest type of encryption, and your computer uses a super advanced version of it every day. How computers do it? The two main types. Computers do the exact same thing, just millions of times more complex. Instead of a simple shift by 1 key, they use massive, complex mathematical keys. But the principle is the same. There are two main types of encryption you need to know. 1. Symmetric encryption, the fast one. This is our decoder ring. The computer takes your data, the plaintext, and a single secret key and mixes them together using a complex algorithm, called a cipher. This creates the ciphertext. A modern symmetric algorithm, like AES, Advanced Encryption Standard, is the global standard. It's what your bank, the government, and your Wi-Fi use to encrypt huge amounts of data very, very quickly. It's incredibly secure. The only problem is, how do you get the secret key to your friend in the first place? If you just send the key in a message, hey, the key is shift by 1, anyone who intercepts that message can now read all your secret notes. This is the key exchange problem, and it leads us to the second, magical type of encryption. Asymmetric encryption, the magic mailbox. This is one of the most brilliant ideas in modern history. It's also called public key cryptography. Forget the single key. With asymmetric encryption, you get a pair of keys that are mathematically linked. A public key, a private key. Think of your public key as an open mailbox. You can shout it from the rooftops. You can put it on a billboard. You can give a copy to everyone. Anyone in the world can use this open mailbox to put a message in for you and lock it. But here's the magic. Once a message is locked with your public key, it can only be unlocked with your one, single private key, which you never share with anyone. Ever. So, if Alex wants to send me a secret message, I shout my public key, the open mailbox, to the whole world. Alex takes his message, uses my public key to lock it, and sends it. A hacker intercepts it, but it's locked. The public key can't unlock it. It's just rubbish. The message arrives. I use my private key, which only I have, to unlock and read it. This solves the key exchange problem. We never had to secretly share a key. It's kind of amazing, right? This public and private key magic is happening billions of times a second all over the internet. If this lightbulb moment is hitting for you, do me a favor and hit the like button. And if you want to keep breaking down these complex topics, make sure you subscribe to the Teleris channel. Also, do not forget to visit us at tealeris.com to see how our advanced agents work. How it all works together, HTTPS and E2EE. Now, let's bring it all home. How does your phone use this? You might have noticed that symmetric, the decoder ring, is very fast, but asymmetric, the mailbox, is very secure for starting a conversation. So, modern systems use both. Example 1. Your browser, HTTPS. When we talked about public Wi-Fi, we said to look for the S in HTTPS. That S stands for secure, and it's a perfect example of this. You type mybank.com into your browser. Your browser, Alex, says, "Hello, bank. I want to talk securely. Please send me your public key." This is the magic mailbox method. The bank's server sends its public key. Your browser then creates a brand new, one-time use symmetric key, a secret decoder ring key. It uses the bank's public key to encrypt this new key and sends it to the bank. The bank uses its private key to unlock the message and get the new symmetric key. Bam! Both sides now have the same secret decoder ring key, and they got it securely. From this point on, they use that super fast symmetric key, AES, to encrypt all the data, your password, your account info, for the rest of your session. It's the best of both worlds, secure key exchange, followed by high-speed encryption. Example 2. Your messages, end-to-end encryption. This is what apps like Signal and iMessage use. It's called end-to-end encryption, E2EE. It means the only people who can read the messages are you, the sender, and your friend, the receiver. Not the phone company, not the app developer, not a hacker. When you message your friend, your message is encrypted on your phone, the end, using your friend's public key. It travels across the internet as rubbish and is only decrypted on their phone, the other end, with their private key. If the company gets hacked, all the hackers can steal is a giant server full of unreadable, encrypted nonsense. Let's bring it all back. We started with a simple shift by one decoder ring. We learned that encryption is just the process of turning plaintext, like meat, into ciphertext, like NFFU, using a key. We learned there are two main types: symmetric, the decoder ring, one key to lock and unlock. It's super fast, but sharing the key is hard. Asymmetric, the magic mailbox, a public key to lock, and a private key to unlock. It's slower, but it's perfect for starting a secure conversation. And we learned that our modern world, from HTTPS on your browser to E2EE on your phone, uses both types together to give us the perfect blend of security and speed. Encryption isn't magic, it's math, and it's the guardian that makes our entire digital, connected world possible. Your action plan for this one is simple. Appreciate encryption. Check for HTTPS every time you enter a password. Use messaging apps that have end-to-end encryption by default, like Signal or WhatsApp. When you see that little lock icon, you now know exactly what's happening: a beautiful, high-speed dance between a public key and a private key. Now, encryption is what protects our data. But what happens when this protection fails? What happens when a company doesn't encrypt their data properly, or a hacker finds a way to steal the keys? The result is one of the scariest and most common events in the digital world: a data breach. In our next video, we'll explain what a data breach is, why they seem to be happening every single week, and what actually happens to your passwords once they've been stolen. I have a question for you. Before this video, what did you think encryption was? Be honest. A magic wall? A firewall? Let me know in the comments. Thanks for watching, stay safe, and I'll see you in the next one.